Good afternoon, good morning, everyone. Welcome to this CS Skills Exchange on machine language and AI, and presented by Samir Kamani. And so hopefully you'll be able to enjoy it. And as a reminder, you can put your question in the doc if you wanted to ask a question async, or you can ask the question as we go along. So without much further ado, Samir, I'll let you go.
Great, thank you, Tabo. So welcome everybody. So today's presentation is a little bit about AI and machine learning. I won't get into the details of AI and machine learning. This is not a course for learning that. There are other resources for that, including our engineering team. Today's presentation is more in the veins of how would you carry a conversation with a customer that is doing some AI machine learning type work and still be relevant to their business case or use case. So that's sort of the crux of the presentation today. And so that's kind of where I want to take it. Now, where I would like to begin is, I was up all night making that little word cloud there. But the thing I want to know is from the audience, please go to this URL, and I will post that URL in our, I can't find the chat window, but if you can copy that URL, and let's see, go ahead to that URL. It is also in the doc. Please put in your answers. I'm just curious to know how much people know with regards to the 4 categories that I've picked. Which is artificial intelligence, machine learning, data engineering, data science. When I say no, I mean more than just have heard about it, right? So I want you to be truthful about, can you carry a deep conversation about what artificial intelligence is, what machine learning is, what is the relationship between the two, what's data engineering, what's data science, those kinds of things. So if you could go ahead and please vote, that would be great. All right, votes are coming in. All right, I will give it maybe 2 more seconds, maybe. Let's see. All right, so the votes are in. The breakdown is sort of thus. Oops, I lost my window there. The breakdown is sort of thus. I've got about 29% of you stating that you know artificial intelligence, 29% of you stating that you know machine learning, about 8% saying they data engineering, and about 25% of you know data science. And then a small chunk of you don't know any of the above, which is great. This is a great start then. This is actually a good presentation, a primer. So that's, so you're at the right place. Great. Now, let me tell you a story about some of my experiences. I am a solutions architect here at GitLab, and most people might think, hey, he knows DevOps, he's good with security, but really, I graduated with a focus in artificial intelligence many years back. Some of you can probably see some gray hair on me. No, when I say many, it's a long time back. Now, in relation to that, my co-author, my classmate from university, and we were bright-eyed young bucks, and we wanted to change the space travel as we would know it. So we devised a paper where we came up with a model on how to build a neural network that would sit on a robotic arm, and it would go into space and collect space debris. Some of you have been kind of keeping up with the space travel recently, know of space debris. You probably heard about a spaceship or a space thing that was exploded up in space and debris is all over. In fact, NASA yesterday mentioned that they were canceling the spacewalk because there was too much of space debris. So we knew that was a problem. And this is back in '96, we wrote this paper. So This is way back when the best machine that was available was a Pentium 586. So that was a long time back. Now, obviously, we have many more devices, many more things that we can do. In fact, our smartphones have more processing power than what we had in a big hunk of machine at the time. So a lot has changed, but that's sort of my background here. Now, Hollywood has really taken the whole idea of AI and really romanticized it, right? So you've probably heard of Space Odyssey, Terminator. You've probably seen the movie. If you have kids, you've probably seen WALL-E. I'm sure you're familiar with Star Wars and iRobot. And there's a nice, interesting effect going on, right? On the one hand, you have these Terminator and Space Odyssey type robots, HAL, ready to kill humans. And then on the other side, we've got the Star Wars robots and WALL-E trying to find life and do good for humanity. So it's really all of the above, and they've done a fairly good job at representing that. But really, the best representation, in my opinion, was The Matrix. If you haven't seen it, please go check that out. It is a really good movie. So why is all this important, right? Is we need to start getting into the discussion of what is AI and how does it all pan out. So really, this is sort of where the world has settled in terms of how to define artificial intelligence. So artificial intelligence from a broad perspective is actually the study of having a computer respond to stimuli just as a human would. So it's sort of replicating humanity, but in an artificial sense with machines. How does that happen? It happens based on learning and teaching the machine to do those things when that stimuli comes in. So therefore, from a definition perspective, machine learning is a subset of technology that is driving the artificial intelligence, okay? And then deep learning is actually doing a lot more analysis and a lot more data and a lot more of whatever learning it is doing to be able to provide the value for artificial intelligence. Now, I've kind of said a whole bunch of stuff in that discussion, but I want to pause here and wait and see if people have questions around this, because this tends to be the most difficult concept, and it tends to be hardest for people to understand, because when you start thinking about artificial intelligence, machine learning, and deep learning, and you go out into the industry and everybody's saying, oh, our software's got AI. Well, what do they really mean? Really, do they have AI? The best approximation of AI currently is GPT-3. And if that's the level of AI that we're expecting, and some company comes up and says, well, we're doing AI, well, they're not really doing AI. So we need to start to peel the layers of the onion and start seeing things as they should be. So the question should be, what is AI? How do you define AI? And then what does machine learning and how does that work in that whole construct? So I'll pause here for any questions, any comments. If anybody wants to come off mute and talk, that would be great too. Let's see. JC, do these layers depend on one another? Good question. They do, because without learning, so current model of how we think of artificial intelligence is sort of how we think of kids, for example. How would you teach a kid to play baseball? You would teach a kid to play baseball by teaching the kid. How do you do the teaching part? You give them appropriate tooling to understand how the game works. First, you give them the rules of the game. Then you give them data of how other players are playing, or what is a good play versus what is a bad play. And that trains the child to do what they need to do. And we're very specific in our use case, it's baseball. sometimes we may take another sport like soccer and offer it as a contrast to tell the kid, you do not kick the ball in baseball, okay, like you do in soccer. So it's good to learn soccer also, but we're learning that to know what not to do in the other place. So there's a lot of that going on. There's a lot of that deep learning, but learning is sort of the core aspect of artificial intelligence. And then now once the kid or machine has learned something and they are presented with that stimuli, they are going to do something about it. And what is it that they're going to do? Now, you might have a kid, or you might have experienced this with kids. And I know Kevin Chassis is a coach. He might actually be able to tell this story better than I can. But you know, a kid goes up on the baseball field and freezes, right? And they're in their mind, they're calculating the probability of something, and they are stuck. They are not able to move forward. In my opinion, the child knows what to do. They are just not able to do it. Machine learning and AI has a very similar relationship, right? Machine learning helps with the action that needs to come out. That is where AI is. AI is a little bit broader than machine learning. Machine learning just gives you the probability. Machine learning tells you what is the outcome of a bunch of yes, no questions, or a bunch of nodes in a tree that are defining what the outcome needs to be. But the decision of what to do with that information is where AI is. So one does feed into the other. So with that, any other questions real quick? What is the technical term then for running a model with stimuli after it has learned? That is, it's a really good question. I don't know the answer to that. It is really just operationalizing the model. That's what they call it at this point in time. I don't think there's any specific term that I can recall around that. All right, so moving on. There is some terminology in the slide deck. I've put the link to the slide deck in the document. I'm not going to read the slides. You can take this home and use this. But understand that each of these has different connotations, different meaning. If somebody comes to you running up and says, we do AI ops, well, that doesn't mean they do anything with a model. It means they're doing some sort of operations thing with AI. And AI ops is actually a subsumed term that doesn't really belong where it does, but some brilliant people came up with it and it's stuck. So I have some other scientific problems with the definitions at this point, but this is the current version of the definitions as they are used in the industry. Now, switching gears a little bit, what is the development life cycle when it comes to machine learning, right? So just understand that machine learning takes a lot of work outside of just getting an application somewhere. It's a little bit different from how you would envision writing an application. So I have to write I don't know, e-commerce application. What am I going to do? I'm going to go talk to people, find out what kind of e-commerce application I need to write, what kind of UI I need to put together, and then I'm going to start building it. And what's going to come out of it is, at the end of it, is an application that does e-commerce. Great. That life cycle could take days, weeks, maybe months, but really it's centered around analyzing the requirements and understanding what needs to be done, and then basically putting it into practice. So the life cycle is fairly short for application development. For machine learning, though, the life cycle is much longer, because how do you learn something? What is the core construct of knowledge? It is data. You need to have data. You need to have knowledge. You need to, and the relationship between data and knowledge is exactly that. Data is just data. Knowledge is meaning of what that data is. And so you need to do that before you can use that in any way. Some of you who have been around the industry a lot probably know this, is when you had searching in Google, maybe 12, 15 years back, you basically typed some terms and it would just go do an exact match of that term. So contextual information was missing at that time. This was way, way, way back when. Then they added the context around it. And they said, well, if you're looking for the word engine and its approximation to the word airline, then you are looking for an airplane engine or something like that. So now you have context around it. That's knowledge, right? So that piece needs to happen in any business context. So where does that lead us to? It leads us to taking data from various data sources, putting it all together, analyzing it, understanding it, creating relationships between it. Then taking that data and using it for a business purpose. Okay, it's a very lengthy process. It's not as easy as saying, well, we want to increase our sales next year, so AI team, go figure out what to do and create an AI that does that. And it's going to probably crash and burn because you don't know what the data has, you don't know how to manage the data, you don't understand the data, and you're trying to come up with some business analysis around it to fit into that data, and it's just not going to work. Not only that, you're probably abusing technology in that situation, because that is something that a simple report can do, and you don't need to build AI around that. So let's kind of focus on what needs to happen and why and where, and be aware and mindful that a lot of AI and ML projects actually fail. And that's because it is a true science. It's a way of analyzing information, coming up with some ideas and theories, testing out those ideas and theories, and then probably in many cases going back to square one because that theory or idea failed. So that iteration and that process is very lengthy. It takes a long time. Now, where does that leave GitLab? It leaves GitLab way at the tail end of that whole process, right? So you've got all this stuff happening, data science, you've got data engineers that are taking data and engineering them, right? So you have 15 different data sources from your IoTs and your machines and this and that and whatnot. And then the engineers are taking that and they're actually constructing information in ways that can be consumed. Data scientists are taking that data and actually analyzing, understanding patterns. They're understanding what's good, what's bad, why is this data necessary, what is the derivative of this data, why should we have that derivative? That's all data science work. And then come the machine learning and model ops folks who basically take that information, construct a model to analyze more data, further data, train it, and then put it into production. And that's where DevOps comes into play, because that's where the coding piece goes. Along the way, there's a lot of code too, so just be mindful of that. But in today's world, people don't see data manipulation as a coding exercise. It's a science exercise that data scientists perform currently. So a little more granularity. I kind of explained all of this stuff, but this is basically what it takes to take a business problem and get it down to a point where it is a deployable model. And as you can see, there are a billion things that are happening. And GitLab can't do a lot of these. A lot of these are tools that are already existing in the industry and are performing a lot of these tasks. So just be mindful that when we get into the industry and we say, yeah, me too, I'm doing machine learning and I'm doing AI, just be mindful that there's a lot of stuff that GitLab cannot currently support in its native way. We can obviously make things work and kind of bend GitLab in ways that it probably shouldn't be and make it happen, but it wouldn't be the right choice. It would just not work in a more scalable, more operational way. Where it can work is capturing the business problem and then deploying the model, and everything in between is just kind of happening elsewhere. with probably some touch points in GitLab. So kind of getting back into, okay, so GitLab can't do all that. Where can GitLab help? Well, GitLab can help where in multiple places. So there is an engineering group that is already existent. Some of you may have seen the contribute discussions, so you're probably aware of it. There's also a direction page, and that link is actually active on the slide deck. You know, feel free to click on that. But basically, there are two things that we are doing at an engineering level. We are creating things within GitLab. So and I'm going to overuse the word feature here, but think of feature as functionality that is in GitLab that is going to support model ops and ML ops processes. So those zillion things that I showed you in that whole chart in the previous slide, some, if not many of those, we are planning on implementing, but it's a long track for us. The second thing that we are doing is we're doing applied machine learning. So many of you have heard of the acquisition of Unreview. Many of you have seen Tanuki Stan channel on Slack that gets fed frequently with information. Those kinds of things GitLab is already implementing and putting it into practice. So a lot of dog fooding going on, or drinking your champagne if you're in sales, but a lot of that is going on right now, and we're working through that piece. What is currently existent in GitLab and can assist with the conversation is to sit with the team that is planning on doing AI and ML and just having a very clear understanding of their business process. So walk with them in their shoes to see what they're doing and help them reduce the chair swivels and the things that GitLab does best, right? Is to take out other tools that they don't necessarily need anymore and orchestrate it through GitLab. So where does that lead us to? So there's the epics and issues, there's source repository, natural use case. A cool feature that we just released is diffing Jupyter notebooks. This is valuable for data scientists. So if you're starting to have that conversation, this would be a very cool place to start that conversation. Orchestration. So GitLab, as you know, has CI/CD and a lot of orchestrating power. It can take all of those tools and automate a lot of that processes for the customer. To add to that, now we have a runner that actually has GPU execution capabilities. So we can actually use the power of GPUs right from natively through the runners and not have to rely on other tooling to do that. And then last but not least, let's not forget, security cannot be left behind. I don't care if you're the hotshot data scientist that's doing the most wonderful AI application, it better be secure. Because guess what is worse than not having AI? It's having AI that is vulnerable and is hacked, so all your results are coming out so bad that AI doesn't work. So you take your pick. You want secure app or not? We provide a lot of security within the system built in. It really makes things better. Naturally, the next stage is the package management. Any of this stuff can be packaged into Python scripts or containers or whatever you want. And then, of course, release orchestration and deployment. So many of you know the breadth of GitLab functionality, but I'm kind of mapping the AI pieces into this by taking the conversation one level up. Okay, tell me about the customer's process. That will be my first question when a customer tells me they're doing AI or ML, because I sure as hell can't fix their AI ML problem, but I can make their life easier, which is in a way fixing a lot of their problem. So that's sort of where the conversation needs to be. So I'm going to pause here for a second, look to see if there are any questions. Let's see, I have 2 questions. Not particular question, but wanted to double down on interacting with technology as a human world being important. Yes, thank you, Bradley. That's exactly what I meant, is interacting with technology as a human would. So if on the other end, If I don't know what is responding, but I believe that a human is responding, then that machine has achieved AI. It's called the Turing test. That's what it needs to pass. And then the next question is, does getting to an AI
Hey,
that field? Yes.
Samir, there's one above Bradley that you missed from Mirko.
Okay, thank you.
I don't know if you can see it in your chat or not.
Yeah, I can. What is the technical term for running the model with stimuli after it has learned? It's basically executing the application. That's what that is.
Yeah, and you had answered before.
Mm-hmm. All right, so JC has one. Does getting to an AI for the field fit like left to right funnel, with the wide side being deep learning, then moving into midpoint as machine learning, and then the short end being AI? That is a very, very good question. In a manner of speaking, it is, but let me think about that. Got a lot of deep learning, a little bit of machine learning, and then AI. No, I would not say it's a funnel. I would say it's actually the way I represented it in that diagram, which is concentric circles, one being a subset of the other. So it's not really a funneling process as much as it is building the foundation that then feeds into the bigger picture. What I mean by that is, for example, at this point in time, the way we see AI is all AI has to have some level of machine learning. But if you took just machine learning, in the current view of the world, machine learning may not lead to AI. It may just lead to probability calculation, statistic calculation, things like that. So it has no AI area. It's just machine learning to provide you with results in a historical sense. So it's not really a funnel as much as it, like I said, it's a functional concentric circles around it. Edmund has placed a Twitter link. Let me go look at that. I'm not sure what that link is. I am having mixed feelings as I'm considering using GitLab some projects because features so valuable. Yes, thank you, Edmund. The feature that is described in this thread in Twitter is actually the Jupyter Notebook diff, and it is very, very useful. All right, and then Hugo, okay, it's been answered. Thank you. I am not looking at a document, so are there questions in the document that I should, maybe I'll get to these at the end.
There's one from Mark Sassari. Is there any CI tool that does more of the ML lifecycle today?
Good question, Marco. So the short answer is not in the way we think of CI. Okay, what I mean by that is, so companies like NVIDIA, Intel, and I believe Dell might be in there too. What they have done is, because they have the chipsets and the GPUs that do a lot of the calculations, and they own that, and they also want the customers to be able to use that technology in a more useful way, have created what they call platform to build and run and build, train and run AI or ML, I should say. And so from that perspective, it has some CI capabilities in it, but it is purpose-built. It's built to interact with those GPUs and things like that that are going on in there. And it's not really the way we would use CI, and then we would infer that this is a GPU connection, so I'm going to do GPU. Like, you know, you don't actually build your code on those CI tooling, although you might be able to. They don't highly advertise that part. What they do is they actually take the AI ML construct and the data construct, and then they kind of merge it together, and they do the GPU training, and then they give you the results and that sort of stuff.
So is there value with GitLab as a CI orchestration tool with their platform, or are we running into each other?
Yeah, no, there's a little bit of overlap there. but there is value. So I actually have worked with a customer in the IC community, in the intelligence community, that actually did that. So they had like the platform, but then they had GitLab where they stored all the code and all of their stuff. But then the GitLab pipeline would feed into the platform's pipeline to do the cycling of the models and then return back the model. So there is value. There is, like in every other tool that we work with, there is some overlap, but there is a little bit of good synergy play where we can actually coexist very well.
Thank you.
Okay. All right. So again, there are a couple of things out there that I would point you to. I'm going to jump into the demo, but before that, I just kind of want to point out that these links are in the deck. It's very sparse right now because I haven't really dug in very deeply to see what other people are actually prophesizing in terms of AI and model and all that stuff. I've basically focused on GitLab at this point. So contribute, I mentioned this earlier, there is a model ops talk that our product managers did. It's a great primer to understand what GitLab is working on, what's the future roadmap. Unfortunately, currently the team is very, very small, so they have a very limited capacity right now, but that sort of stuff is described in there. This link over here is the model app section link in the handbook. Keep that handy. That is going to probably frequently change as more team members come on board. Externally, this has been my favorite. Okay, so if you don't know anything about our AI, or if you know a little bit but want to kind of just be mindful of what work goes into making machine learning happen and AI happen, Cassie Kozyrkov is a data scientist at Google, and she has these wonderful, beautiful presentations. Sound quality is awesome. Presentation quality is awesome. I really highly recommend you look at those and just kind of keep track of what comes out of that thing. So these were actually presentations that she put together for Google. But Google is now essentially open sourcing and they're putting it out there for everybody to consume. And these are wonderful videos. So I can't say enough about that. Please do look at that. Now with that, I'm going to switch to the demonstration. So everybody's familiar with GitLab, right? So I don't need to go into the construct of what this is, but I've created a project. I have hooked it up to a Kubernetes cluster in my Amazon AWS cluster. Okay, so that work you're going to have to do anyway. So that I'm just kind of describing what I've done in terms of just the setup. I got a project, I've got a cluster, I hooked it up with that. The second thing I did was I created, and again, I won't take full credit for this project. I've actually stolen some work from the internet and borrowed, open source, whatever you want to call it. I've taken that work and I've actually added to that. So there are two Python scripts. Basically, these Python things, they're very simple. If you look at the app API, essentially it opens up a URL endpoint and it makes it available to all IPs on port 5000. I've done this for a purpose. For now, just go with it. This is just a simple demonstration. And in that main method, all it does is basically it runs a pickle file. And I can describe to you pickle files at the end of this call if you're still interested in what a pickle file is. And then it basically runs the model. It predicts based on the data that I pass in, provides me with a prediction score, and that's all it does. Very, very basic AI, or sorry, ML application. Not something that I would go to head-to-head with against a data scientist, but this makes for a great demo. It's like the hello world of machine learning. Okay, that's what this is. So I've got that, and then I've got a notebook. So I've got a Python notebook that I created. which is where I did the data analysis part. So imagine a data scientist working in their Python notebook, Jupyter notebook, and creating this. And then they're like, okay, now I've got what I need. I've created a model out of this. I need to push this to production. In today's world, that's a lengthy process for them because they have to take this Python notebook, package it, and then that packaged file, which is essentially a pickle file, which is the model inside it, they have to give it to a development team. That development team takes it and puts the wrapper around it, which was that Python script that I put together, and then deploys it somewhere. So if you think about it, as a data scientist, either I need to know how to do all that, or I need to rely on somebody to do that for me. And then now you've got that classic problem of, well, do you have the right version of the model that I sent you? Did you update it? Did you train it? Where's the run book? Like, did you run these steps? Did you do that? All of those questions come up, right? So we've got the same problem there. It's just the persona is different here. So again, I won't go into the detail of this particular construct here with the notebook. Needless to say, we now actually present the contents of the notebook right within the GitLab window. So for a data scientist, I can see this. I can see, oh, there it is. I've got my decision tree classifier. I'm training it. I'm predicting it. And then I've got an accuracy score of, a little bit over 90. 90. So that's great. I've got a 90% score on this. This is an awesome thing for me. So I'm going to use this classifier, which is the algorithm, to do the data analysis. I'm going to train it. I'm going to run it. And I can do this stuff. So what I did with that is I then deployed that with my CI/CD pipeline. And I'll show you the pipeline, and you'll see, and you'll be like, hey, that looks familiar. That looks like my auto DevOps pipeline. You got it. This is auto DevOps at its best. All I did was I put my Python code. I basically rigged it up with auto DevOps. I've got my build step, which actually builds that whole thing and the container that comes out of it. I've got my security steps, which are actually picking up a lot of security findings, as you can see. That's pretty cool to show to a customer. It is actually putting it into a DAST environment. I'm running a DAST. It's not a good DAST solution right now because what I built is an API. So let me take a step back on the application that I did. The application that I've run basically produces the probability score based on a data set that I send it in. And so it's really very, very simplistic. I send some numbers, it gives me back a number. The actual application that would use all of that is an external application that I'm not worrying about here, because presumably that's your UI or that's your Ajax call, whatever it is that's doing that. I'm just building a REST API that gives me scores based on this using the model that I have. And then, of course, I'm putting it into production. So now I see in my chat, somebody said, cool, can we see it run? Absolutely, great question. So I did all that. Let me get into my Insomnia. So that's the main branch. So like I mentioned, I pass it a bunch of data and it brings, so I send it and it brings back a data score. This data score is a 2. So what is exactly happening here is in my notebook, what I'm doing is I'm training it, and then I am asking for it to give me a score or bucket, basically. It's a decision tree. So it's bucketing this kind of data into a bucket. So what I'm saying is if I get data that looks like this, put it in bucket 2. If it's a different set of data, and I've done actually that over here, then put it in bucket 0. So I'm essentially just kind of bucketing it, and I'm giving it, I'm having the machine learning basically bin things for me. It's a simple binning sorting kind of algorithm. It's very, very simple. There's nothing much going on in there. Okay, so that's what it's doing. So I've actually got it deployed into my AWS environment. I've got an API endpoint. When I send data to it, it actually brings back a 0. Now, some of you may say, hey, that was easy enough. I could have put this into a container and shipped it. Yeah, you could have, but you would have had to manually build a container to do this. If you're a data scientist, think about it. Your whole purpose is to try and figure out what is the best model, what works best, not worry about the tooling, about which container is it going to go in, how is it going to reside in AWS, what's it going to run. I don't care about all of that. All I care about is the model that I've created good or not good. So what I've done for that is I've actually created a merge request. Sorry, I went to the issues, but I'll go into the merge request that's tied to the issue. There it is, where I actually modify the Python notebook. So I go back into my Python, sorry, my Jupyter notebook, and I actually start making changes. And guess what? I can see the changes. This is where I'm diffing my notebook. So that's my notebook, and that's where I'm diffing it, and I can see the changes that I've made all across the board, right? I can see that, let's see, let's go over here, forget the cells, forget the pickle dump. Essentially, this is kind of where I've done the biggest change, is I've modified from a decision tree classifier to a different classifier. Essentially, I think I use a random forest classifier. Okay, so that's what I did over here. And if I were to go look at this code, which let me go show that code. There it is. Come on. And there's my code. And in this case, when I trained it, I got an accuracy score of 100%. So this is, I used a different algorithm here. I used a random forest classifier as opposed to a decision tree classifier. And if you read up on it, you'll realize that decision tree is basically a binary tree or some sort of a tree structure that actually identifies what the outcomes needs to be. Random forest is a whole bunch of those trees with polling. So it says, run this data through all these different forests that I've got and tell me what the score comes out to be. And so your prediction scores tend to be a little bit higher on that. Your accuracy tends to be a bit better. So as a data scientist, I just did that in a branch, in a merge request. And guess what? This is where GitLab shines, right? Is I was now able to deploy this into my running environment, into a review environment, right? And if I go back to my Insomnia, I actually have a different URL. It's my review app URL, as some of you may notice. And when I send the data to that, for the first data set, I'm still getting a score of 2 for the binning. For my second data set, I'm getting a different binning score. It's a 2. So suddenly, my results are changing based on the model that I'm using. I have both models live, one in production or production-like environment, and one in my review app, and I'm able to see the difference. And it's got the full trained data set with, or full trained data set with the model in it. And so I have a higher confidence on this working. I'm not using my laptop resources to do this. I'm using AWS compute resources to do this. Think about that. I have just opened this up for the entire team to be able to contribute, right? I'm no longer dependent on just my laptop doing this the right way and shipping this. I can now open this up for collaboration and be able to get a lot better through this whole process. That is key construct of what GitLab is, and that's what I'm showing you. So
we got 5 minutes left there, so maybe before time up.
Yeah, absolutely. Thank you for that reminder. So I've got a couple questions here. Is there a general performance between different models like non-classifier? Sorry, I meant non-classification models used by most. yes, there is a difference in performance. Like I mentioned, a decision tree is a simple decision tree process where it creates a model, so the models run faster. A random forest is where it does polling against a whole bunch of trees, so it can take some more time to come up with the answer. So there is performance degradation there. Also, if there are other types of algorithms that I may choose, they may have their own. So every algorithm is different. And this is something that the data scientists know what to do and how to do it. And there is tooling for doing that. And that's the Jupyter Notebook, where when I'm pulling, in my case, I'm using scikit-learn. When I pull that in, then the algorithms come with it, and I know which ones to use, or maybe I can create my own or whatever. So there is a lot of that going on, but that's all that is all the part that what the data scientists, data engineers do. It's not really in the DevOps realm, but we can facilitate that, right? So that's kind of where GitLab really, really shines. Okay, so with that, I'm gonna pause here. I'm gonna open it up for any questions, any thoughts. Anybody want to come off mute, please feel free to do that. This is an open discussion. Let's have it.
Hey, Samir, this is Chester. This is an awesome presentation, and thanks for taking the time to put it together. The question I had was, are you seeing any signs or patterns in the industry of consolidation of machine learning tools and projects in general?
No, it is still in the infancy stage. What I'm seeing is that tooling is sold as part of the machine, because the construct is, hey, you want to buy GPUs to do machine learning. Well, guess what? I will sell you tools to get the best use out of that. And so they've kind of cornered the market there. There isn't much of a consolidation. Data scientists may use those tools that are available or create their own set. They tend to use GitHub to store all their stuff, and they tend to use scikit-learn and Python and things like that to actually process and run things. There really isn't much of a consolidation. It's just a smorgasbord of stuff. So I think our messaging is at the right time where we're kind of going, but we're early in the process. But if we take this message now, I think we can have a huge impact on shaping that future. So I think this is the right time for us to be doing this.
Awesome. Thanks for that.
All right, I think we have one more minute. Last questions.
Yeah, it's not in the doc or even in the chat. So.
Okay, well, if anybody has any further thoughts that they want to talk out with me about machine learning, AI, please feel free to reach out to me. Obviously there is a product group, there's an engineering group, there's a lot of resources within GitLab to support you. But from a sales perspective, I believe this is the first presentation that actually shows a running application within GitLab and AWS environment doing this sort of stuff. So, and I'll be sharing this out shortly. So this is in a good state now to be shared out. So yeah, I'll be doing that. Keep an eye out for that.
Okay, cool. Yeah, so I tried to take some of the questions, Samir, from the chat and put them in the doc. So later on, if you can go into the doc and do async answering, I tried to answer as much as possible based on what you were saying.
Yeah.
I may not have captured all of them, but if you can just go behind and add or correct what I've put in there, that'll be great.
Yeah, no problem. I will do that.
Yep. All right. Thanks, everyone. Hope you have a great week and a great Wednesday, and hope to see you in a couple of weeks.
All right. Thank you.
All right. Thanks,
Thank you,
Samir.
Samir.